Hello guys, trust you're doing fantastic. In today's video we're going to be talking about the BCD subtraction of 10's complement. We are going to be considering case 1 where we have to subtract a smaller value from a larger value. Now let's go over to the rules. Rule number 1 says take 9's and 10's complement for the subtrahend. 2 says add it to the minuend by using the BCD addition. Alright, so 3 says if the result is greater than 9, that means BCD is invalid. Now to correct this issue, we need to add 6 to the result. Alright, so this is basically similar rules that we have seen in the previous examples. Now rule number 4 says shift carry to the next bit. And rule number 5 says if n carry is generated, then discard it. Now let's see how we can apply these rules to a given example. Alright, so let's take this example as a case study. Alright, it says, what is the 10's complement BCD subtraction of 2.1 from 10.2? Now that means we're going to be subtracting 2.1 from 10.2. In that case, the solution is going to be 10.2 minus 2.1. Alright, so which also means 2.1 because we need to represent this value to have the same size with the minuend. So if you must carry out the addition operation successfully, we need to represent the value such that both the minuend and the subtrahend has the same length. Okay, so the same size means they should have the same length. Like you see, 0.2 has 3 lengths. Okay, the length is 3. Now we have 2.1. We need to look for a way to make 2.1 equal to the length of 10.2. So in that case, we're going to add 0 in front of 2. Now the 0 in front of 2 does not does not in any way impact 2.1, so it's the same. 2.1 is the same as 2.1. Alright, it doesn't change the value. Alright, so in this case we need to carry on with the operation. Now for we to take the 9's complement of 2.1, it means that we have to subtract every digit from 2.1 from 9. So every digit in 2.1 from 9, we have to carry out this operation. So we're going to be subtracting 1 from 9, 2 from 9, 0 from 9. So we say 9 minus 1 is 8, 9 minus 2 is 7, 9 minus 0 is 9. So we have arrived at 97.8. Alright, so in this case, the next thing we need to do is to take the 10's complement. Alright, so taking the 10's complement means adding 1 to the result. Adding 1 to the 9's complement. So all we need to do is to add 1. We say 8 plus 1 is 9. 7 plus 0 is going to give us 7. 9 plus 0 is going to give us 9. Alright, so in this case, the next thing we need to do is to represent this result in BCD form. And the BCD form is nothing but taking the 4 bits of each of these digits. Alright, the corresponding 4 bits. So for 9 is going to be 1001 dot. For 7 is going to be 0111. For 9 is going to be 1001. So we have taken the BCD form for this value. Alright, so all we need to do is to add this result to the minuend. Alright, so we have written it out as 1001.0111.1001. Now let's add this result to the minuend. So the BCD form of the minuend 10.2 is going to be 0 0 0 1, all right, which represents 1. Now this 0 is represented by 0 0 0 0, everything 0, dot. Now this 2 is represented as 0 0 1 0. All right, so at this point, let's carry out the addition. So it's going to be 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, dot. 1 plus 0, 1, 1 plus 0, 1, 1 plus 0, 1, 0 plus 0, 0. Now 1 plus 1 is going to be 0 with a carry of 1. Now 1 plus 0 is going to be 1. Now you have 0 plus 0, 0. 1 plus 0, it's 1. Now remember, the rule says if the result is greater than 9, what happens? It said that means the BCD is invalid. Now to correct this issue, 6 needs to be added to the result. Alright, so let's check if the result is greater than 9 or less than 9. So we say 1 0 1 0, this will give us 11. So 11 is greater than 9. So in this case, this result is invalid, BCD invalid. Now dot, let's check this result. We have 0 1 1 1, this is 7. 7 is less than 9. Now let's check this result. We have 1 0 1 0. Now this gives us 10. So 10 is greater than 9. In this case, we need to correct this issue by adding 6 to this, and then correct this issue by adding 6 to this part. So in that case, we need to add 6 for correction. So we have 0 1 1 0 and 0 1 1 0. So this is 6. Now let's carry out this operation. Let's start from the right hand side. We have 1 plus 0, it's 1. 1 plus 1, 0, with a carry of 1. Now this one is indicated here. So 0 plus 1 is going to be 0 with a carry of 1. Now this one is indicated here. You have 1 plus 1 plus 0. We're going to have 0 with a carry of 1. This one is indicated here. Now, so this 1 plus 0 is going to give us 1. So we have the 1 brought down at this point. Alright, so since this value is less than 9, so it's valid. So we'll just bring this down. We have 0 1 1 1. Alright, so for this other part, since we need to correct this by adding 6, we say 0 plus 0, 0. 1 plus 1 is 0 with a carry of 1. So this carry is indicated here. So say 0 plus 1, it's going to be 0 with a carry of 1. So this one is indicated here. Now say 1 plus 1 plus 0 is going to be 0 with a carry of 1. So this one is indicated here. So literally, we bring down this one. I'll say 1 plus 0, bring down this one. Alright, so in this case, we have seen, according to the rule 5 says, shift carry to the next bit. Alright, so we have carry has been generated at this point. So we shift it to the next bit. Alright, we carry out the addition. Alright, now the rule says that if end around carry is generated, we need to discard it. Alright, so we have n around carry generated at this point, so we have to discard it. Alright, so let's carry out the operation. Now for this part, you have 1, we have 0, we have 0, we have 0. Now this carry that is generated there is shifted to the next bit. So carry out this operation. So 1 plus 1 is going to be 0 with a carry of 1. 1 plus 1 is going to be 0 with a carry of 1. So this one is indicated. 1 plus 1 is going to be 0 with a carry of 1. So 0 plus 1 is going to be 1. Alright, so since this carry, n around carry at this point is discarded according to the 6th rule. So all we need to do is to bring down 0, bring down the 0, bring down the 0, bring down the 0. So if we have to convert these BCDs into decimal, we're going to have this point is going to be 0. This is 1 0 0 0 is going to be 8. Dot, we have 0 0 0 1. So this is going to be 1. Right? Alright, so converting this BCD back to decimal, we're going to have 0 0 0 is 0. 1 0 0 0 is going to be 8. Then 0 0 0 1 is going to be 1. So in this case, we have 081 08.1, all right, now which is also the same thing as 8.1. All right, like I said, the 0 does not change what this value is, does not impact it in any way. All right, it's just to help to maintain the same length or the same size. So this is what we're going to get as the final answer. So if you've gotten to this point, you have gained sufficient knowledge when it comes to the BCD subtraction of 10's complement case 1. So I'm going to encourage you to pay attention to the subsequent videos in this channel. Alright then, enjoy this video. Bye.